Move to question number 3. A liquid is placed inside a closed container. Some of the liquid evaporates. The pressure of the vapor above the surface of the liquid increases to a maximum value. This maximum pressure is called saturated vapor pressure. The table shows data for the saturated vapor pressure P at a different absolute temperatures. Plot a graph of log P versus 1 over T on the opposite grid. Use additional columns for your processed data. So we will calculate log P as well as 1 over T values. Log P, so log of 7.8. So that is 0.89. So you can calculate the respective values of logarithm of P for rest of the values. So 1.23, 1.54, 1.82, 2.08, and 2.32. Then 1 by T. So 1 over 308, that is 0.00325. Then 0.00310, 0.00296, 0.00283, 0.00272, 0.00261. Okay, so based on this value, we are going to plot the graph. We'll keep log P on our y-axis and 1 over T is on x-axis. So you can see the log values, maximum it goes up to 2.32. So we can start something like this because its minimum value is just starting from 0.8. So 0.8, then we can take here 1, 1.2, 1.4, 1.6, 1.8, 2, 2.2, and this is 2.4. Then 1 by T value we can take. This is actually 0.00325. This value we can rewrite it as 3.25 into 10 to the power of minus 3. This we can write it as 3.10 into 10 to the power of minus 3. This is 2.96 into 10 to the power of minus 3. 2.83 into 10 to the power of minus 3. 2.72 into 10 to the power of minus 3. 2.61 into 10 to the power of minus 3. So what I'm trying to do is, I would like to start from 2.6, 2.7, 2.8, 2.9, 3, 3.1, 3.2, 3.3. Okay. So this value is in 10 to the power of minus 3 Kelvin raised to minus 1. When it is 0.89, it is 3.25 10 to the power of minus 3. So you can mark the respective points here. 0.89 means 3.25. Then next is for 1.23, 3.1. Then 1.54, 2.96. Then for 1.82, it is 2.83. 1.82. Next is 2.72, 2.7 to 2.08. And finally, the last value, 2.61. It is 2.32. Then after noting down the points, you try to draw a line of best fit. So this is our line of best fit. Okay, fine. Now, after drawing the line of best fit, because we did this plotting, then determine the gradient of the graph. So how we will find the gradient? Rise over run. So we take randomly 2 points and then find the rise over run value. So what is the gradient value? So here the 3.2, what is the difference between 3.2 and 2.9? It's 0.3, and this value is 1, and this is 1.6, 1. 1.66. So take the difference. 0.66. So the gradient is equal to 0.66 divided by 0.3 into 10 to the power of -3. So what is the value of gradient you are getting? You can just input in your calculator 0.66 divided by 0.3 multiplied by 1000. So I'm getting -2200 as the gradient. Now C part. The third part of this. The gradient of the graph of log p versus t is given by minus x divided by 2.30k, where x is a constant with the unit joules and k is Boltzmann constant. Determine the value of x. So what is the gradient? We got -2200, and that you can equate this to minus x by 2.30 into Boltzmann constant k. Then you try to figure it out, the value of x. So x is equal to 2200 multiplied by 2.30 into Boltzmann constant. You will get that one from our data sheet, 1.38 multiplied by 10 to the power of -23. So if you are multiplying approximately 7.08 multiplied by 10 to the power of -20 joules. Now, liquid boils when the saturated vapor pressure is equal to atmosphere pressure. Determine the boiling point of the liquid in degrees Celsius when atmosphere pressure is 100 kilopascal. Determine the boiling point of the liquid in degrees Celsius when the atmosphere pressure is 100 kilopascal. So you can use the same graph itself. So for that, you can calculate what is log 100, because this pressure is given in kilopascal. So what is log 100? Log 100 is equal to 2. Now, for what value of t this is going to happen? This is going to happen for 2.75. So for log 100, the 1 by t value is 2.75. So 1 by t is 2.75. The temperature is 1 over 2.75 into 10 to the power of -3. So that we will get it as 364 Kelvin. So the temperature is actually 364 Kelvin. Now our aim is to find this boiling point in degrees Celsius. So answer is 364 minus 273, and that is 91 degrees Celsius, because we will be using this conversion formula, like Kelvin to degree Celsius means you subtract 273 from this. So the answer for this question is 91 degree Celsius. Hope you got the idea.